Okay, so on to 7-3, multiplying powers with the same base. Again, this has rules, but if you don't learn the rules, the pattern behind it will save your keister. Alrighty, so multiplying powers with the same base for every non-zero number a and for every integer m and n. So notice here, again, these are non-zero numbers, right? We've discussed the reason behind this before. And then the exponents are, for right now, they're going to be integers. Otherwise, if they're not, it changes things up a little bit. But if I have a times a to the m times a to the n, I get a to the e, technically m plus n. Here's what that means. So if I have 2 cubed times 2 squared, notice same base, right? 2, and integer powers. That means is I have 2 to the 5th power. Now how do I get that? Well, 2 cubed means 2 times 2 times 2, right? And then times 2 squared, 2 times 2. How many times is that? 1, 2, 3, 4, 5. Hence, 2 to the 5th. The rule is just a shortcut for you. You can do it the long way every time. That'd stink. Now what that also means is you do subtract them too. So if I have, hang on a sec, let me shrink this up a little bit. There we go. If I have, let's say 2 cubed times 2 to the negative 2. The rule would say that'd be 2 to the 1, right, or 2. Now if you think about the shortcut and think of what we learned so far, 2 cubed, I'm sorry, I should say this, right, negative exponent means it goes to the denominator. So that's like having 2 cubed over 2 squared. Now if you expand that, you get 2 times 2 times 2 over 2 times 2. These guys cancel, that's just 2, right? So the rule works either way. Again, long way, short way, it's up to you. Now I've decided to go ahead and include the examples in the same video here since it was such short vocab. But again, to look at it one more time here, here's the property. Here's a couple of examples. 4 to the 3rd, 4 to the 5th is 4 to the 8th, right? B to the 7th, b to the negative 4 is b to the 3rd. Again, you end up subtracting them. So down here, again, why it works, I just showed you, right? You basically just end up adding up all the bases anyway, or the number of bases. So an example here, if we have 12 to the 4th times 12 to the 3rd, notice same base. That's 12 to the 4 plus 3, which is 12 to the 7th. Same base here. Now again, using this parentheses to force us to take the negative with us. Negative 5 to the negative 2, negative 5 to the 7th is negative 5 to the negative 2 plus 7, which is negative 5 to the 5th power. And again, if you don't believe me, throw this into the denominator like you're supposed to with the negative exponent and cross out the matching ones. So let's take a look at the gottets here real quick. Take a look at A. I have 8 to the 3rd times 8 to the 6th. That becomes 8 to the 9th. Here we have 0.5 to the negative 3rd, 0.5 to the negative 0.5 to the negative 8th. That is 0.5 right to the negative 11th. And, again, that would throw it into the denominator, but we're not really asking for that at this point. And then here I have several, it works with as many as you have. If I have 9 to the negative 3rd times 9 squared, that's 9 to the negative 1 times 9 to the 6th, which ends up being 9 to the 5th. Alrighty, so multiplying the same powers in algebraic expressions, right? So our example here, what is the simplified form of each expression? So here I'm going to take a look. These are all multiplied out, so I have to figure out, same bases, right? Z and Z right here. So the 4 and the 9 get multiplied to 36. Z to the 5th times Z to the negative 12th is Z to the negative 7th. So I end up with 36, Z to the negative 7th. And again, simplified means no negative exponents, so that throws that Z to the 7th into the denominator. That's a lot to spit out. Okay, so similar thing here. 2a times 9b to the 4th times 3a squared. Notice the a and a, same base. So those guys are going to become a cubed. You can look clear down here if you prefer. 2 times 3 is 6 times 9 is our 54. And nobody to combine with the b to the 4th, so it comes down here to the bottom. Alrighty, what is the simplified form of each expression? Again, a through c here. So, taking a look, Same basis. Don't forget there's a 1, by the way, right there. So I've got 5 times 3 is going to be our 15. So you multiply in the numbers. And then x to the 4th, x to the 9th, x to the first power is going to become x to the 14th once I add up all those exponents. B, we're going to multiply the coefficients first. So negative 4 times 7 times 2 is negative 56. I expect you guys can all do that. And then the c cubed and c to the negative 2 becomes just c, right? 3 minus 2. And then nothing to combine with the d squared, so we leave it alone. And then c, we've got a j squared and a j1, so that becomes j cubed. We're going to throw that 12 back out in front. And then k to the negative 2, which is going to force that k into the denominator, so that's going to be 12j cubed all over k squared. And then D, explain how to simplify this expression. Well, essentially, right, you're going to add up all the exponents. So it's x to the a plus b plus c, whatever a, b, and c happen to be. Now in the last section we did scientific notation, so guess what? We can use those rules here. So, if I want to multiply this expression, we go ahead and multiply the coefficients first. So it's sort of like coefficients, right? So 3 times 5, first off, gives us 15, right? And then the tens, we're going to keep that same base, so times 10 to the 5 minus 12 is going to be negative 7. Now the thing is, this is not scientific notation, right? Because this is not between 1 and 10. So I'm going to move that to 1.5 and then give myself the extra decimal place here. So times 10 to the negative 6 is what we end up with there. Now again, if you're not sure, if you want to write all the zeros back out and then take the other 0 back, you can do that too. It's up to you how you accomplish that. So, you all right? Oop. Alrighty. So, simplified form of this one in scientific notation. So we've got 7 times 4, that's 28. So we see right off the bat we're not going to be in scientific notation. Times 10 to the 8 plus 5, so that's the 13th, right? Now again, not between 1 and 10, so we're going to give that 2.8 and times 10 to the, and then again giving ourselves back that extra decimal place makes this 14. There you go. Alrighty, so multiplying numbers in scientific notation again. Story problems, I love that. It says at 20 degrees Celsius, 1 cubic meter of water has a mass of about 9.98 times 10 to the 5th grams. Each gram of water contains about 3.34 times 10 to the 22nd times 10 to the 22nd molecules of water. But how many molecules of water does the droplet of water shown below contain? Okay, that's a lot of numbers. So, what we're looking at here is volume, right? A droplet, right there. 1.13 times 10 to the negative 7th meters cubed. So that's a really, like a droplet's really small, right? Hence the negative 7 there. It's going to get a whole bunch of zeros over here. So I've got this droplet of water times the mass of water and times the number of molecules, right? Multiply all that out. So again, multiply, we're essentially going to call the coefficients. I know 10 is not a variable, but we're kind of treating it like one in this case. So 1.13 times 9.98 times 3.34. Multiply that out. And then negative 7 plus 5 plus 22 is 20. Not scientific notation. Owes us a decimal point there, right? End up with 3.77 about, right, times 10 to the 21st. Number of molecules of water in a droplet. Now, again, little droplet of water, but think of how many zeros that is. Like, bang, 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 clear out here, right? That is a ton of zeros. So there's still a lot of molecules in that little tiny droplet of water. Okay, so here we've got, I'm going to circle the numbers we're going to multiply. So we're going to multiply 200, right? The 9.98 and 3.34. So we've got 9.98 times 3.34 times 200 times 10 to the 5th times 10 to the 22nd. Now, I multiply these guys out and I end up getting 666.64 times 10 to the 27th. Not scientific notation. So it owes me 1, 2, 3 zeros, right? So we're going to 6 point, we'll call it 7 if we round it, times 10 to the 30th, because I take those other 3, right, the other 3 zeros I just took from here. So 1, 2, 3 spaces here, and I give it to this guy. So 6.67 times 10 to the 30th is our molecules of water, right? So there you go. And again, think about how many zeros that really is. There are 29 zeros behind this, heading out this way. That's a lot of zeros.